Hello everyone. I have a couple TVs that I'm going to do some videos about. This VIZIO here, it has a backlight issue. I'm having a hard time to find the backlight with a good price. When I get okay from the customer to fix the backlight, I'm going to make a video about this one. VIZIO E601i-A3E. This TV, it has a backlight issue. The customer said he took it to someone, other technician, checked the TV, did some work, checked the boards and everything, and confirmed that he said the backlight is bad on it. Then they give him the price, and the customer was, the price is too high, they don't want to do it. And after a couple of months, he did bring the TV here for me to check it and let him know if I can do it for a better price. So I try to start from what the other technician said, but that's my mistake. I took the TV all apart, I took the screen, check everything to reach the backlight. So here, let me show you the problem. I plug the TV to the power, and I plug it to the watt meter. So this is going to tell me when the TV is on, how many watt is taken and all that. So here I'm going to turn on the TV. So about 8 watt. So there is, the white light is there. The optical port, it has the light, but there is no backlight. You can see the LEDs are off. So let's check here. We have power on. So this one on the ground is a DC here. Then we check the power on. The power on is a 3.3 volt. That's good. After power on, we have 12 volt. It's good. Then ground, and we have another 12 volt, maybe somewhere here. So that's 12 volt. The T-cone on, it has the voltage, so there is the signal to turn on the T-cone, and this pin is the T-cone voltage, 12 volt. So there is all the voltages for the TV to turn on, but we don't have no backlight. So this is the first check we did. So next I'm gonna flip the TV and I will check the backlight. Show you what I did. Yeah, this connector is horrible. So I disconnect this cable here. Let's go into the backlight and we check the backlight. Or we plug the backlight tester, and we have some testing points here. We have the positive here, then we start going one by one. So that side it works, this one it works, this one works, this one works. This half here, it works. So let's check this one. Like you. This one works, and works. Go to the other side. Same thing, the positive and the red. Works, 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 works. So this half works. And here works, 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 works. As you see, this backlight here is a 4 strips. There is one here, that's 2. It's number 3 and number 4. And you can see the black wire for half, blue wire, then the green and the gray. All the LEDs, they turns on, they works. And it seems okay. The voltage in the LED tester shows good. So what could be the problem? To understand how this power board works. So we have 2 output transformers. This one here for the 12 volt and standby voltage. And this one here is for the backlight. That's this section here for the backlight. This section here for the voltage that's going to the main board and going to the screen. This transformer here is step up voltage. So we did check the voltages here, looks good. And I'm going to check the voltages in the output of these diodes. Turn on, because that one over there it show like, so it's a half watt. This means the TV is off. So we have each watt now. The TV is on, and let's check the voltages in these diodes. No voltage in these diodes. Yeah, this transformer is getting the power from these 2 MOSFETs. These MOSFETs, they get the power from the capacitor. That's get the power from the step up voltage. The black of the multimeter and the plus. And we're going to check in the source to see if there is a power coming to these MOSFETs. So we have 160, the second source. Well, we don't have nothing here. 160 here. So this MOSFET is going to power this MOSFET. This MOSFET is going to send the voltage to the transformer to go out. We have the power here, but we don't have the voltage here in the source. That's, of course, if we don't have this, the voltage in the source is not going to transfer no voltage to the drain. And the drain is connected to the first coil of this transformer. Another thing, when I check this MOSFET, as you did see, we had 160 volt. 160 volt is not enough. This transformer here, the step up circuit is not working right. Because when the TV on, we should find 360 coming to these MOSFETs. If we check here, let me try to do it again. We have 160 volt in the voltmeter. Should have a 360 here or 390. And for the big TV, usually the backlight circuit, it's work with the 390 volt. It doesn't work with 160 volt. The TV, it turns on now. the TV, it has the picture, but the picture is dark. Something wrong, I think, in this part here. So let's take this board and we check it. So I'm gonna solder plug to here. So I'm gonna plug the power and let's check the voltages. The big part here is the ground. So here in this pad here we have 4 volt. .3 volt here. .12 volt here. Then the other pins, no voltages. So we have one pin, it has 4 volt, and the other pin here is a 12 volt. I may make the video a little bit longer so I can explain more stuff about the power supply. So this power supply, it's give the 12 volt here. As you see, there is just 2 traces here, the output of the transformer. There is just 12 volt. This one here is the ground. This one here is go to this diode. The output, the diode is go to this capacitor, all of them, to this coil. And here you can see 112 volt is go to this jumper to here, and here we have 12 volt. Good. The other 12 volt, it's go to these MOSFETs, and it stop over there. One of these MOSFETs, this one here, is for the screen. When the main board send in the signal, send in 3.4 volt to the pin, it's a T-cone on, that's going to send the signal to this MOSFET to allow this 12 volt to go here, and from here is going to go to the screen. The second 12 volt is this one here, to this pin here. This 12 volt is feeding the main board, like feeding the sound IC, feeding other parts in the main board. This 12 volt is going to become like 5 volt for the HDMI, for the USB, and for other. The 12 volt that's coming direct from this trace is going to this pin. This 12 volt in the main board is going to become 3.3 volt, 1.2 volt, 1.8 volt. That's powering on the processor, powering on the controller, the EEPROM, for the TV to be in the standby. So here, now let me flip it. We have, that's the T-cone on pin that I told you is came from the main board. This is the 12 volt T-cone that's controlled by that MOSFET. Okay, this is LED on. We have 12 volt here. This 12 volt is always on, but this 12 volt here, it's not. Yes. And we have the AC detect, we have 4 volt here. For me to push the power board to turn on the other voltages, the T-cone voltage and this 12 volt here, I'm gonna need to give some voltage to the power supply on, PS on. I'm going to get it from this AC detect because it has a 4 volt, it's close to 3.4 volt. Going to make a jumper, and you're going to see we're going to turn on the other voltage to finish testing, so we can test more parts in the board. So unplug the board, and let's do the jumper. We're going to do the jumper between the pin number 2 and the pin number 3, just like that, a little solder jumper. So now we have 4 volt in PS on, so in the output is this MOSFET. Now we have 12 volt. You can see this pan, we didn't have the voltage, now we have 12 volt. We always had the 12 volt here, even the TV was on the standby. So let's finish testing the board. When the board is on, we need to have 390, not 160. So the board is still working as in the standby mode. The 12 volt voltage is on. The T-con pin is 0 volt. We need to have 4 volt here or 3.4 volt here for this MOSFET to turn on. So we are not worried about the T-con voltage because I did check the picture and we have a good picture. This is the part that I want to check. This one here, this transformer, this MOSFET here, and this power IC. This power manager IC, this one is controlling step up voltage circuit. This circuit is here. This one here is controlling the backlight circuit. This one here is controlling the 12 volt and the main board voltages, this one here. So the problem is we having the problem that the TV, it doesn't, this voltage, it doesn't go to 390. So let's check this chip here. This chip to turn on, it's need 2 things: start up voltages and VCC voltage. So to check the part here, we're going to need to use the ground from the B capacitor, and be sure this part here is a high voltage, so be sure to don't touch something with your hand or burn something, because it's so here 160 volt. You can see there is some capacitors here, some resistors. These resistors, to lower the voltage, that is going to go to here. So 160 here, 94 volt, 47 volt. It's go 47 volt here, and here we have 1 volt. Yeah, this 1 volt here is very low. I'm going to check all these resistors to be sure none of them is tested open, especially this one, because here we have 47 volt, here we have 1 volt. So always the VCC, that the voltage that's feeding this IC, you're always going to find a little capacitor. This capacitor here, that's the VCC of this capacitor here. That's for that IC. This capacitor here is the VCC for this chip. This capacitor here. This capacitor here is the VCC of this chip. So it's easy for you to check the VCC voltages in that capacitors. The VCC voltage should be like 12 volts, 16 volt, something like that. We have no voltage in the VCC. Of course, if we have no voltage in VCC, this chip is not going to work. This chip is not going to send us the square wave. That wave, you can follow this trace here. It's go here. It's go to the gate of the MOSFET. The gate of the MOSFET is going to cut the 160 and send it to this transformer, and from this transformer is going to send it to the capacitor. The transformer is going to send 390 to the capacitor. Then we're going to have the 390. So this capacitor, at the first we test 160, but normally when the power on, when the TV is on, that 160 is become 390 in the same capacitors. So the VCC is this, the plus of the capacitor, and we're gonna follow this trace. Let's go to this jumper here, to here. We follow this trace. It's go to this transistor here. So we're always gonna use, so this is the negative side. You can see all these traces come from here. That's the negative side of the capacitor, is mean the ground, and this is the same here. That's the ground of the high voltage. So here we don't have voltage because we don't have it here in the capacitor, of course. We don't have voltage in the base, and we don't have voltage in the collector. If we don't have voltage in the collector is not going to pass the voltage to the emitter. So we check this capacitor here, we have no voltage. So let's follow the trace. We have a jumper here, so let's keep checking. We have no voltage in this jumper. This jumper is go here, then it's go to this transistor that's connected to the optocoupler. We go back to here, we have a diode. There is no voltage here. There is no voltage here. In this diode we have two low ohm resistors, 5R10. This is 5.1 ohm. So that resistor is very low. So there is 5, and there is 1 ohm here resistor. We have another diode here. We have 17 volt in this diode. So in this capacitor we have the voltage. You can see this capacitor, it has the voltage. This IC work. That's why we have the 12 volt. That's a good thing to understand. This capacitor here is the VCC of this IC. It has the voltage 17 volt. That's why this IC it's work fine. But this IC and this capacitor we have no voltage. That's why this IC is not working at all. Okay, and it's good. So we have the voltage in the output of this diode. This diode is getting the voltage from this pin of this transformer. This pin is giving this diode and this diode the same voltage. We have the voltage here, we don't have the voltage here. likely this, we need to check this diode here. Okay, let me explain more about the, because we are talking about the transformer. In this transformer there is two coils. This is the positive side of the capacitor. There is a jumper, it's go here, it's go direct to this pin of the coil. The coil it's here and to here, so there is a wire to here, and from here you can see there is a jumper, and from that jumper we have the output of the MOSFET. This one here is for the 12-volt coil. That 12 volt that we're gonna find it here. This transformer, it has another coil. So here is one coil, and here is the second coil is from this pin. If you follow it all the way to the negative side, look, here is the negative side. It's go here, there is a jumper, and it's go here. And this is the positive side of the coil. The coil doesn't have the polarity, but we say this is the in and this is the out. When this MOSFET start current and sending the voltage, alternative voltage to this coil here, this coil is going to make a magnetic field. That magnetic field is going to transfer it inside this small coil here to the voltage. This coil is going to power this IC, and is going to power this IC, and it will power this IC too. So here, yes. Look, this is the positive side of this capacitor here. Here is a jumper. It's go all the way to here. It's go to here. It's go to this transistor. Then this is like a switch on off. Then it's gonna allow it. It's go here, it's go under this capacitor to here, it's go to this capacitor. This capacitor is a VCC capacitor, it's go to this resistor, it's go here, and it's go to inside the chip. And that is why, because we have no VCC here, we have no voltage for the VCC, and this chip is taking the VCC from this diode too. So now all the fingers is pointing to this diode. I'm still going to check these resistors just to be sure. Yeah, let me discharge this. I'm going to discharge the capacitor, the big ones, because we are going to be working in the high voltage in the primary side. So just connect it to a solder iron, and I'm going to use this one to discharge the capacitor. Okay, now the capacitor, discharge it. Want to be sure any voltage here, very little volt. So this is 225. 225 is mean 2.2 mega ohm. Is it 2.2 mega ohm? No. So still going down because the capacitor still has some charge. And here is so almost 1 mega ohm, because it's connected to many things here, that's why. Here the same thing, almost 1 mega ohm. And here, so this resistor is good. All of them, they tested the same. So let's test the diode. So this is the good diode. So it's give us a reading here. It doesn't give us the reading here. This diode. So it's give us 1.2 volt here. If we flip, yeah, this diode and this diode is the same diodes. This should be having like closer reading. Both of them is a VCC diodes. Okay. Right, this is the diode that we are having the problem with. You can see that diode, there is a brownish around it. This means, yeah, this diode has some problems before. So let's take that diode and measure it out the board. Alright, that's the bad diode. So no reading this way. And this gives us a reading this way. Look, this is like a good diode. 0.6. So no reading this way. .6 this way. So the logic, our multimeter is said this diode is good. It has a reading one way, it doesn't have the reading the other way. We are not going to believe in this multimeter, because when I was desoldering the diode gets hot. I can feel it still warm. And a lot of components, when it gets warm, it start working alright. Transistors and some MOSFETs. So we're gonna wait till this cool down, then we're gonna test it to be sure. So I'm gonna use 2 multimeters just to be sure. So this one is give us 0.6. If I flip, open line. So this multimeter test the diode is good. The diode is not hot anymore. So 0.6 here. If I flip, this one it tests the diode good too. Are we give up and believe this diode is good? I don't know. This diode here next to this one, it has a good voltage and they have the same source. We have the voltage here, we don't have voltage here. So definitely this diode is bad. Especially if there is no short. If there is no short here. So let's put this one on the ground here. No short here. Plus this low ohm resistor is good. It's good. So the voltage is coming to the both diodes. We don't have the voltage here. We don't have it here, but we have it over there. So the battery in it is weak. That's why I have to plug it every time I want to test. It can't read the diode. Yeah, now it's read it. What's going on? Now it doesn't read it. Now it's read it. Now it doesn't read it. So sometime it reads, sometime no. We are not going to go with that. We need something that always work. So I did have a board similar to that one, and they took this diode from it. So the diode number is IN4007. Yeah, IN4007. So let's put the diode and we test. That's not going to hurt nothing. You can see that brownish. That's making. Yeah, look like this diode, it has some overheat. You can see the leg of it is like brown. So we respect the polarity of the diode. Here and here. So the diode is installed, right? Yes. Okay, let's test it. So we know the board is working right. If we have 12 or 16 volt here, and that's going to go all the way to the VCC, to this capacitor. So let's plug the board. So I plugged the board. in this diode here. Let's go to the DC. So in this diode here we have 16 volt. In the diode we install it, we have 12 volt, so it's good. And we're gonna check in our capacitor. This capacitor here, the positive side of the capacitor, we have 11 volt now, so that's good, because at the first we have 0 volt. And this capacitor here and the VCC of the backlight power manager IC, we have no voltage because the backlight is not plugged in. So let's check here in these capacitors. We have 320 volt. So the voltage is double now, 320. So I think we are good to go. Let's plug it to the TV and we will see if the backlight will turn on. I put the screen together. It looks like there is no damage to the screen. That's great. Let's turn it on. So it's stuck at 7 watt. So it means just a standby. It's not powering on yet. Okay, we got the white light. We got the VIZIO logo. Backlight works. TV works. So that's what it was. It was the step up voltage power IC manager VCC. It was missing because that bad diode. The diode that sometime it tests good, sometime it doesn't test. So it's not all the time the multimeter is right. This is all I wanted to show you and I want to share with you. Thank you for watching. Please subscribe and see you next one.